Okay, hey y'all. We are at it again. Okay, look, started learning, getting a little bit better every day. I actually went ahead and pasted all of my number lines, so let's just hope that they're going to be of adequate size. I think they should be. And these actually kind of pasted all in order in a way, you know what I mean? Okay, so we're going to finish solving inequalities. For this problem, instead of it just being an inequality and, we just kind of look at it, graph it, and then write it in interval notation, we're actually going to have to solve the inequality first. So the inequality that we have is, just kidding, 9x to positive 2 less than 8x. I guess I can stop doing that for now. 8x minus 1. Okay, so I just noticed here that this is very similar to the equations that we know how to solve. The only difference, y'all, is that inequality symbol. And so what we're going to do is actually isolate our variables together on the same side. We're going to move and make sure we have just our x's on one side, and our terms that don't have x's are going to go to the other side. So what I'm going to do is actually the inverse of a positive 8, which is a negative 8. What you do to one side, you have to do to the other. 9x minus 8x is just x. Bring down my positive 2, less than, those cancel, negative 1. Okay, let's move our 2. We would do the opposite, which is a negative 2. I get, my thumb hurts really bad, I don't know why. I get an x on my left-hand side because those canceled. Less than 1 and 2. They're both negative, so since the signs are the same, what you do is you add them together and you keep their sign. What I end up getting is that x is less than negative 3. Okay, so my x values can be the values that are strictly less than. They can't equal, but they can be strictly less than negative 3. Less than negative 3 tells me the left side of negative 3, right? And it also tells me that I'm going to use a parenthesis. So I'm going to go to my negative 3 on the number line, and I am going to draw, don't you know what color I'm using here? I guess that one. I'm going to draw my parenthesis. Now, because my values are less than negative 3, that means it's going to open up to the left, because all of the numbers on the left-hand side of negative 3, like so, are going to be smaller than negative 3, which it didn't tell me to stop, so just got an arrow going right there. Now, as far as writing this in interval notation, do you remember me telling you that if it goes forever and ever in the left direction, what you are approaching is a negative infinity? And we know we always use a parenthesis there, right? And then I already have my parenthesis on negative 3. Those are the things that you pull down off of this number line to graph. So we would have parenthesis, negative infinity, comma, negative 3, parenthesis. So this inequality is the same as this interval notation is the same as that visual representation of it on a number line. This is basically just saying that all of my x values can be from negative 3 all the way and everything smaller than that. It just can't equal negative 3. Okay, so for this second example, this is a really important one, y'all. The equation that we have is negative 4x less than 20. I know it's like, why is this important or more important than the one we just did? Like the one we just did kind of had like a little bit more steps to do. And this one you can tell doesn't really have that many steps to do. But what is important is the fact that there's that negative sign. I'm going to tell you why it's important. So it's very critical that when you divide or multiply by a negative, you flip the inequality sign. Very important. When you divide or multiply by a negative number, you flip the inequality sign. So if you notice, this inequality sign is a less than. It would become a greater than. But let me go ahead and let's do that work. I need to solve for my x. It's being multiplied by -4. I would do the inverse of multiplication, which would be division. So divide by -4. Whatever you do to one side, you have to do to the other. So I know on the left-hand side that -4 divided by -4, that becomes 1. So the only thing I'm left with is x. But I cannot forget that because I divided by a negative number, right? Because I divided by a negative number, I need to flip my sign. So it went from less than to greater than. And then look on the right-hand side, if you do 20 divided by 4, we get 5. Signs are different, so we get a -5. Okay, so if we actually put this on our number line, this is telling me that my x values can be greater than, and it's strictly greater than, -5. So to mix it up a little bit, at my -5, I know I'm going to the right? What's on my -5? Well, it's a parenthesis, and it's going to open up also to my right. Now, if I'm going to the right forever without stopping, I'm actually approaching a positive infinity, and I know I use a parenthesis there. So now let's read this number line from left to right. I have my symbol, which is a parenthesis, my value, which is a -5, comma. It's going on forever. It didn't tell me it stopped. So I get an infinity. And then I have my closing parenthesis. So equal, equal, equal. All of those things equal to each other. Okay? Okay. So let's do this one. What do I have? I have 6x plus 5 plus x less than 3x. Just kidding. Less than 3 plus 2x minus 1. I can't tell if that's a brace. Let me see. I think that might be a 13. So negative, so that'd be a 4, that'd be 5, negative, -2, -3. Okay, I'm thinking this is a 13. We're going to start solving it as if it's a 13. Oh, you know what? I pulled this from the homework, and 9 to, nope. Did. Now the real question is, did I pull this from the homework? Okay, so the beginning, and then we solve it. I didn't do that one. 9x, I know this one's 6x plus 5. Okay, so I didn't use the homework to come up with these problems. I'm going to do 13 because there's no reason why I would have used a brace, right? Like I don't have a brace on each side or anything. So the fact that that kind of looks like a brace and kind of looks like a 13, I'm just going to agree and say that that's going to be a 13. All I have is the question and the answer, y'all, like the interval notation. Too hard for me to solve both sides of these in my head. So kind of just, step the difficulty game up just a little bit. We're actually going to do what we've been doing, which is isolate the variables. What I mean by that is get off the variables on one side, get off the numbers on the other. I want to first combine like terms. And what I notice is 6x and x would give me 7x. I've got a 5. Oh, that's it. There's my inequality symbol. So I actually just have a plus 5 less than. We can go ahead and do the math here. It's a plus 3 and a negative 13. What I would get is signs are different. We would subtract, keep the sign of the larger. Plus 2x. Now I want to move that 2x. So I do a negative 2x. Looking on the left-hand side, 7 minus 2, it's going to be 5x plus 5 less than negative 10. I'm going to move my 5. I get 5x cancel less than. That would be a negative 15. Ooh, it was a 13. Perfect. I'm going to move right here. Okay, so I can tell that what I need to do is divide by 3, and what I get on the left, why did I say 3? It's because I know that the answer is 3. I hate it when I do that. I'm not going to divide by 3. Okay, I look at the actual numerical value that's multiplying my variable, and that number is 5. So I divide by that exact value, which is going to be 5. And whatever you do to one side, you have to do to the other. Now, y'all, left-hand side cancels. I get x, and then my inequality is less than. Right-hand side, 15 divided by 5 is 3. Signs are different, so it's negative. Okay, great. That's what I was supposed to get to. So that's the inequality. And I know it's the inequality because it has an inequality symbol. Okay, so what we need to do is, let's read it. X is less than negative 3. So this is saying that my values of my x are all of the values less than negative 3. Parenthesis, and it would open towards the line I drew. Less than, going forever, it's going to be a negative infinity. Now let's actually read this from left to right. We get parenthesis, negative infinity, negative 3, parenthesis, right? So, oh, hello. Not the same color. There we go. So now let's actually bring all of that down. I get parenthesis, negative infinity, comma, negative 3, parenthesis. One is an inequality, the other one is interval notation. Right above us is the graph. Okay, so this problem is going to be negative 25 less than or equal to 4x negative 7 less than or equal to 1. So this one definitely looks different, right? I've got 2 inequality symbols. I've got stuff going on all over the place. What I'm going to do, I need to notice that my x value is in the inside, right? It's in between both of these inequalities. My final answer is going to look, I'm wondering where we did that problem. How can I tap out? My inequality, whenever I get done answering it, is going to look similar to this problem. Do you see I've got my x in between the 2 inequality symbols? It's going to be similar to that, okay? So where am I? Right here. Okay, so what I'm going to do to solve for this is I'm going to work from the inside out, and whatever you do anywhere has to be done everywhere. Still like a balancing game. Looking at my x, I have 4x and I have a negative 7. I know that I want to do what's the easiest mathematically first. So that would be to subtract, I'm sorry, not to subtract, to do the opposite of the -7, which is a +7. So I add 7, being sure to keep everything balanced. Whatever you do to one side, you have to do to the other. Okay, so if you do 25 and 7 and you combine them together, because they are different signs, where is it? There you are. You do 25 minus 7 equals, I get 18. They're different signs, so I did the subtraction. But what you do is you keep the sign of the larger, less than or equal to 4x, those canceled, less than or equal to 1 plus 7 is 8. Okay, so now I notice that my x is being multiplied by 4. You need to do the opposite of multiplication, which is division. Whatever you do right here in the middle, you need to do on both sides, keeping everything balanced. -18 over 4. I could divide both of those by 2, and I would get a -9 over 2. Less than or equal to, cancel, I just have x. Less than or equal to 8 divided by 2. 8 divided by 4 is 2. So this is my inequality. Now, let's actually graph this. I noticed that those are both less than or equal to, it means I'm going to have brackets. Both of them are going to be brackets, right? And now the values that they're on is a -9/2 and a +2. So a -9/2 is going to fall somewhere in this area. That wasn't technical, but in this area. And then I've got a 2 right here. So this is telling me that my x values is in between this area. So I can go ahead. I know where 2 is. I can go and do my bracket there. My -9/2, y'all, if you do 9 divided by 2 or use your calculator, you'll actually get the decimal answer. So, but what we can do here is just a little quick long division. Actually, it would just be division because it's not like a ton of numbers or anything. And I get 4.5. So I now know more accurately, without any kind of guessing, that 4.5 is where my bracket goes, and that's a -4.5, which means it's here. And this represents the values that my x can be. And so if I just bring that information down for my interval notation, I get bracket -9 over 2, parenthesis 2, bracket. My math lab's going to want that in that form. I believe, I don't think they, because this is also equivalent to what? -4/2, -4.5. All of those are the same. I did the division to know where to graph it, like to know where to put my symbol. I'm not too positive which form my math lab wants. So let me know if I'm saying something completely wrong. Okay, so to my knowledge, that was all of my graphing problems. I do, though, however, have a problem that goes a little bit like this. Okay, so let's just say, Dalton scored. I have it written down. Dalton scored an 81 and a 91. You can write on his first 2 math tests. What does Dalton need to score on his 3rd math test for his average? Zoom out a little bit. For his average to be at least an 86. 86. So I've got 1 score, 2 score. I don't know the third score. I know it's an average, and I want it at least 86. There you go. There's my inequality, y'all. So it's only one problem on the homework like this. Average is the sum of terms divided by the number of terms. So this tells me my sum of terms is what? 81 plus 91 plus, what did he get on his third test? Exactly. Like that's what we're trying to figure out is what do you need to make on your third test, right? Right there. What do you need? We don't know it. What does his score need to be? So we have X. That's my unknown. So do you agree with me? That's going to be the sum of his test, right? To get the average, I need to divide by the number of terms. 1, 2, 3. Then it told me, that's not even a word. Then it told me that the reason why we're doing this is because we want his third test to give him an overall average of at least less than or equal to. It needs, oh, sorry, I read that wrong. At least. See, I do it all the time. I think least, I think less than. Totally just randomly happened. And it happens to everybody. So don't beat yourself up. I need his test score at minimum to be an 86. That means that his score can be an 87, an 88, an 89, a 90, a 100, of course, anything. But at least the smallest number that it can be is an 86. So that means that I need his average to be greater than an 86, or okay, it can also be an 86. At least it's greater than or equal to 86. I was sitting here thinking about not having my calculator. And let's do this. Okay, so what I notice is an inequality. I need to solve it. I have a fraction on the left-hand side. I know how I can cancel that fraction. I multiply everything by the denominator. That cancels right there. And I get 81 plus 91 plus x greater than or equal to 3 times 86. 200. 3 times 86 equals, 258. So 258. Now let's look at this. 81, 91, 2, 17. I get 172 plus x greater than or equal to 258. Don't I move my 172? Cancel. X equal, C, y'all, you get so used to saying equal. X has to be greater than or equal to, now let's actually do the subtraction. I would get 6. What is that? It's 8. 1 minus 1 is this. There we go. Dalton needs to make at least an 86. So that's saying it can equal 86. But of course, ideally, he makes greater than 86. Okay, so his third test score needs to be greater than or equal to 86. And doing so will make sure that his average is at least 86. That's not always going to work out that way, though, y'all. Okay, I think the last problem, I just don't have anything written down for me. No, is that it? Okay. This example, this is what I was thinking at first. Test scores 87, 96. Want it at least an 89 average. 87 plus 96 plus x. 3. Okay, see, I was right. Or was I right here? Oop. Yeah, I was right. His test score needs to be at least 86. So this is saying that it can be over 86 and it also can be equal 86. In this particular problem, we're doing 89. What I ended up getting here, I'm just going to go ahead and show y'all this. You get 87. I'm like writing all weird. 96 plus x. Why did I do that? That's 267. I get 183 plus x greater than or equal to 267. Okay. Now you do the subtraction, and this is saying his third test grade has to be greater than or at least equal to 84. I don't want y'all to think that just because this said 86, his test grade needed to be 86. Okay. His test grade needs to be at least 84 to have an average of 89 or above. And you could actually plug this in and let's see, 87 plus 96 plus 84 divided by 3. So that would be 183 plus 84 is 267. And then if I divide that by 3, I get this 80, should be 89. 267 divided by 3. 89. So do you see how if I was adding a 90 here or even 100, I for sure would be at least 89 for my average. Okay, sorry for that confusion there, y'all. Hopefully I didn't confuse anybody too much. Y'all, that ends 10.6, which means we now have all of the material that we need to take our second exam. If y'all have any questions, make sure y'all ask. Thanks. Bye.